This time we're going to be talking about RPF, or reverse path forwarding. In our agenda for this lesson, we're going to cover what's the expected routing behavior and what is packet spoofing. We're also going to learn how URPF checks allow us to pretty much verify whether spoofing behavior exists. We're going to discuss the two URPF modes, strict versus loose, and how they deal with spoofed packets. We're going to learn about the feasible paths feature offered in Junos to support asymmetric routing. And we're also going to learn about fail filters, or URPF fail filters to be more specific. All right, let's begin. Now, before we start this lesson, I want to give a small disclaimer. Throughout the lesson, we will be using addresses from the private address space. But in some instances, I'm going to pretend some block of private IP addresses is a public block of IP addresses. This is to avoid any legal complaints or complaints from IP block owners that I'm using their blocks for examples. Okay, so just when I indicate something is supposed to be public, just pretend it's public. Make sense? Right on. Okay, well, this is the way routing should be. You can see here a router with 4 interfaces. 3 of them are internal. One of them goes to the internet, which is fast Ethernet 000.0. Okay. Now, from interface 3, a packet is sourced from 192.168.10.34. That's the source address, directed to 10.10.10.5. The router sees the packet, looks up the destination, and forwards the packet. Notice that by default, the router does not make any verification on the source of the packet, okay, or any decision based on the source of the packet, just the destination of the packet. All right. Now, this one is sourced from the internet. This is one of those instances where we're going to pretend that the source 172.25.15.9 is a public, okay, and it is destined to 172.16.10.44, which is on interface 1 on the router, internal interface. We send a packet, and it goes through properly. It has the right source coming from the internet, has the right destination. That's just the way typical routing would work without spoofing. Now let's have a look at actual spoofing. So, a hacker on the internet has learned about the internal networks and is now trying to exploit the relationship of trust that exists between interface 3 and interface 2 networks, and it's going to pretend to be sourcing the packet from 192.168.10.9, which is supposed to be on interface 3, and it's going to destine it to interface 2 and its associated network, which is 10.10.10.0/24. In this case, .3 is the host. Now, notice that the packet is going to enter via an interface, fast Ethernet 000.0, which is not associated to that private IP address. Is spoofed, and without any particular check-in or restriction, it will reach its destination. Okay, we want to avoid this from happening. So what would happen if we're using URPF? If we're enabling URPF specifically in strict mode, the hacker's gonna send the packet, but then upon entering in fast Ethernet 000.0, the router is gonna see something's wrong. Okay, so it says, hey, hold right there, right? This packet should be entering via fast Ethernet 003, not 000.0. So the packet is denied. It has failed the URPF verification. Good. So let's just talk some URPF highlights you need to know. First of all, URPF is not needed all across the topology. Okay. Do not overburden every router, because this takes memory and processing. So do not overburden every router with URPF. Just use it on edge routers to untrusted networks. Again, URPF increases the packet forwarding engine memory consumption, so choose well where you're going to implement it. URPF is available in 2 modes, namely strict mode or loose mode, and we're going to learn the differences in a moment. Now, strict mode is preferred oftentimes, and also if you require to execute URPF checks in environments that support asymmetric routing, you need to add an additional piece of configuration for this to work properly, okay? Because normally URPF checks drop packets in asymmetric routing environments. Alright, let's talk about URPF strict mode then. So in this case, in strict mode, if there's a default route for any unknown destination, guess what? A default route matches all, right? Matches everything. So you now might wonder, well, if a default route matches anything and it points to the internet interface, then anything that comes through via that interface, it's valid. Because even if it's not a specific route, it's still a route. You know, it's valid. You know, if interface 3 falls, like it drops, for some reason that network goes down, the interface goes down, then the router will try to send packets towards 192.168.10.0/24 via the next available route, and that would be, in this case, the default route. You and me, we know that it's not going to work because that goes to the internet, right? But it's still a valid route. So strict mode specifically avoids this confusion from happening, and it says this packet is not entering via the best route there is to this network, okay? Hence, I'm not letting it in. Make sense? So that's why it's called strict, because it says, yeah, whatever, there is a default route, yeah, but this is not a specific route towards that destination, so that packet is not allowed in. That's why it's called strict, because it's strictly, if it knows it has an interface towards this network, it is strictly via that interface that it'll allow packets, okay, not via the more general route. Now, it's different if we're using loose mode, and you do not ever want to use URPF loose mode if you have a connection to, if you have a default route, pretty much. You never want to use URPF loose mode if you have a default route, because what you're doing is pretty much enabling URPF to do nothing. You know, spending the packet forwarding engine memory in order to do nothing, because whenever something matches the default route, it is allowed. And guess what? Everything matches the default route. Okay? So the router here says, okay, well, interface is not the most specific path, but it's a route to the matching packet still, so I'll just allow it. I'm just a loose guy, right? This is something you don't want to do. You might want to use loose mode only in environments where you know a packet might enter it via different interfaces, but there is no default route. Okay, good. Now, besides these two options, you also need to know some environments will need to support asymmetric routing. So for example, say here from domain A perspective to domain B, maybe there's only one route. It's not doing any load balancing or of any sort. It's just using this particular route, okay? But from the domain B perspective, and these routers which are in domain B cloud, they might be doing load balancing even per packet. So they might be returning traffic to domain A via two different routes, and the problem is RPF by default will not like this. RPF says, well, if that path is inactive, you know, if that path is inactive, I'm not really forwarding packets to that network via this path. Even if it's a possible valid path to the network, I'm denying packets entering this interface because it's not the one I'm using. Okay? This is the problem with URPF and asymmetric routing. Now, using the feasible path option is what will allow us to enable this behavior. Okay? So the feasible path option will allow us to receive traffic even from inactive paths. And again, we're talking about the perspective, the outgoing perspective. Okay, the outbound perspective. There's one inactive path, but from the inbound perspective, from the other domain, they take it as a valid path. So it's an asymmetric situation, if we enable the feasible path option, we are going to be allowing this to pass RPF checks. So it's important for you to know this. Now the last feature I want to talk about is called fail filters. Okay, a fail filter is a special type of firewall filter created for URPF. Okay, so fail filters will act on traffic which is failing the URPF check. They are not defined like regular firewall filters. They have a special syntax. They are called URPF fail filters. Okay, now it's important for you to know that you might want, for administrative purposes, you might want to log packets even if they're dropped by URPF. But if you're trying to make a counter, for example, or you're trying to log those packets via a regular firewall filter, the firewall filter is not going to log it. Why? Because the URPF check will happen first. So the firewall filter is never going to see it, even if it's a drop. However, if you do a fail filter, then you can log those packets because it happens after the URPF check. Okay. Now you can allow a fail filter to actually override the decision of URPF. Okay. Overriding the decision meaning maybe a packet failed the URPF check, but it matches the criteria you define in the fail filter, so you're gonna allow it anyways. So you're just, bypassing RPF's decision on the subject and allowing the packet in. That's also another possibility provided by URPF fail filters. Okay, before ending this lesson, I'd like to have a look at the configuration for URPF. Notice that plain URPF, it's configured under the interfaces, under each interface where it's going to be applied. Okay, so in this case, you can see the configuration snippet where it is applied under Fast Ethernet 000 Unit 0 Family INET. Okay, the way it's applied is simply putting RPF check after Family INET. Make sense? Now, if you do not do anything else than RPF check, it's going to apply strict mode by default. If you want to use loose mode, you need to specify it as it is here in the snippet. So mode loose will override the default, which is to use strict mode. Okay, so this will do RPF loose mode on the Fast Ethernet 000 interface. Now you can also include a fail filter, as we learned, and the way to do that is after the RPF check, you specify their fail filter and then you put the name of a filter. A fail filter is simply a firewall filter applied here under RPF check fail filter. Okay, so you just call the name of the filter you have defined. Now, what is a common use for fail filter? You can see it here. This is maybe the most common use for URPF fail filter. If it is that DHCP needs to be allowed on that interface. Okay, this is a commonly used fail filter. So what it's doing here is allowing DHCP. Okay, notice that source address is 000/32 because that's typically the source address used by DHCP, and the destination address is 4 octets of 255. Well, if it matches this criteria, it'll accept it, else it'll reject it. Okay, that type of filter is done so that the valid DHCP requests are not dropped by a URPF setting. Finally, the feasible paths, which we learned about, which allows for environments with asymmetric routing. It's configured directly in the forwarding table. Remember I told you that using URPF increases packet forwarding engine memory? Yes, it's because URPF operations happen at the forwarding table. So you need to set it up in set routing options, forwarding table, unicast reverse path, feasible paths. The other option is active paths, but that's available by default. If you want to enable feasible paths, you need to specify it right here. Now, as you're aware, this is the last topic we needed to cover before we end this series. It's been quite a ride. It's been 3 courses for this video series, And I know it's been a lot of work, a lot of labs, because you cannot simply cover a certification like this in a short time or without any decent amount of practice. So I want to first of all congratulate you for reaching this far, for following the exercises, for rewinding and repeating the things you don't understand, and for investigating further. You are now ready to become JNCIA Junos, and I'm very proud of you. Okay, so let's now talk about, just briefly, let's talk about the exam before we finish this particular series. The JNO-102 exam is a written exam in the sense that it uses an automated engine. Okay, for those of you who have applied for exams from Cisco or VMware, it's a similar concept in the sense that it's an engine in which where you need to go to an actual proctoring center or exam proctoring center, like Pearson VUE in this case, and then it's an automated exam with a counter, okay, because there's a time limit. It's 90 minutes, and then they start sending you multiple choice questions. Okay, I cannot tell about the exam more than what it is published, because there is an NDA and we need to respect that because of ethics. But I can tell you that Juniper exams in general are challenging in the sense of time management. Okay, what do I mean by that? They give you a lot of questions. Okay, more questions than other exams you might be used to. In this case, it's 70 questions in 90 minutes. So how long do you have to answer each question? It was simply as dividing 70 by 90, and that's 0.7 minutes. Okay, it's not even a minute per question. You guys follow me? It's 0.7 minutes per question. So that means you really need to know what you're doing, and you need to have practiced before. This is a must. You must have done practice exams before. One other thing you need to know is these exams typically use a lot of snippets. Okay, they use a lot of configuration snippets because you're supposed to know how to read them, and sometimes they take some time to load. Okay, sometimes they don't load immediately, and unfortunately that also, I believe, I'm not sure, but I believe that might depend on the testing center, but they might take some time to load. So you need to factor that in before applying to your exam, and you need to know that you need to be fast. So you really need to know your material quite well. Okay, this is not to scare you. JNCIA Junos exam is not an exam famous to be too difficult. It is not. However, you need to be careful with those details, and of course that the more you advance in Junos, the more complicated they are. I can tell you that the JNCIS and the JNCIP exams are quite tough. JNCIA is the first one, so it is obvious that it's maybe the easiest one, but you must not underestimate it. Okay, I wanted you to know all of these factors before you attempt the test. Now, one good thing, and I've told you about this in the past, is that Juniper does offer this web page, which is called the Fast Track program, right? So www.juniper.net/us/en/training/fast track. And in the Fast Track program, they give you books. Okay, they give you some reference books for free that you can download digitally, and they also give you an option for each exam, from the JNCIA Junos to each and every JNCIS or specialist level. They give you a chance to do a pre-assessment exam. Now, something about the pre-assessment exam. These are questions which were going to be included in an actual test. Like, these are questions that are product of the working of the same people that create the tests. Now, what is the criteria for them to put them on a pre-assessment exam rather than on the test? I am not sure of that. I cannot tell. But I know for a fact that this comes from the same source or the same people who create the questions for the test. So this is a really good exam. It is just 25 questions, and then if you get a 70% or more, you will get a discounted voucher, okay, for the Pearson VUE exam. Now, on the time I did it, it was a 50% voucher, so it was a quite a good reward for passing the pre-assessment exam. Okay, quite good because you're saving some money from the test. So this is a great deal. And so what I would do is start practicing those 25 questions, and do this timing yourself. Okay, give yourself a tough timer. Like, I mean, if they give you 90 minutes for 70 questions, try to do the 25 minutes in 30 minutes or less. Sorry, the 25 questions in 30 minutes or less. And start timing yourself like that. And if you don't finish, then start to practice again and again and again. Practice a lot, practice a lot. Not to memorize questions, but just to tune up your skills for exam taking. One thing is your skills for networking, and unfortunately one other thing is your skills for exam taking. So you need to time yourself and make sure you are you're not insecure and you're fast enough to answer and to answer correctly. Okay. Well, I want to thank you very much again for going through this series, and I surely have had a great time gathering all of this material and recording this for you guys. And I hope that you will join me on the upcoming series on JNCIS ENT, where we're going to learn and become specialists in Juniper Enterprise Routing and Switching.